Okay, our next section is going to be about arithmetic sequences. We're not going to be doing series. You might see a couple of review questions, but this is more about sequences and what an arithmetic sequence is. So take a look at our learning goals. We want to be able to recognize the arithmetic sequences and find the indicated term of an arithmetic sequence. Find the arithmetic means between two numbers. So let's get started and start with a few definitions. Now, an arithmetic sequence is something that is a pattern to it, and the pattern is that we're adding by a constant difference. So when we say we've got a constant difference there, we could be adding a plus 6, we could be adding a plus 2, we could be adding a negative 5, we could be adding a 1/2. The size of the number does not matter as long as every single term changes by that constant difference. That's what arithmetic is about. So think arithmetic, adding and subtracting. That's what we learned when we were doing arithmetic back in elementary school. So an explicit arithmetic sequence takes us from anywhere in our term right to where we need to be. Explicit takes us directly. It's another way to think of the word explicit. Takes us directly to where we need to be. Arithmetic, adding and subtracting. So now think about this. If you had just an easy add 2, add 2, add 2, add 2, if you evaluate this, from this first term to, let's say, just to get to that 8, we would have an adding here, here, and here. So the 8 is in the 4th spot, but we only added 3 times. So notice, we need our first term, that would have been our 2, plus n minus 1. So we're looking for our 4th term we were talking about, so t sub 4. And we're doing 1 less because with 4 terms, we only do 3 multiplications. So n minus 1 would give us that 3 multiplications times that constant difference of a 2. And you can see why we'd get the answer of 8. Okay? So that's our thinking. Now, an arithmetic mean. Look at the sequence that's here. Terms between any two non-constant terms, non-consecutive terms. So if we have an arithmetic sequence and we have an arithmetic mean, 5 and 11 are considered to be consecutive, but 5 and 17 are not. So 11 would be considered the arithmetic mean between them. If I said 5 and 35, they are not consecutive terms. So that means there are 4 arithmetic means between them. Okay? But we knew that 5 and 35 came from an arithmetic sequence. So that's going to help us find those other terms in between. All right, so with that, let's go and find out some of the problems we're going to do today. This one happens to be in a recursive setup, remember, so look at it. Find the 10th term of the sequence defined by this equation. Now, we definitely want to work on reading these, and they wanted 10 terms, so 3, 4, 5, 6, 7, 8, 9, 10. Some of you, that's the easiest thing. Just put the little tabs down. Now, here we go. The first term is 7, if I'm reading this correctly. Then, all other terms in my sequence. Why do I say all? Because it says for n greater than 2, so that would mean the 2nd term, the 3rd term, the 4th term, the 5th term, etc., etc. Then it says will be calculated equals previous term plus 6. So here we go. I'm on the 2nd term. The previous term is 7. Add 6 to it. I would get 13. I'm on the 3rd term. Add 6, 19. Add 6, 25. Add 6, 31. Add 6, 37. Add 6, 43. Add 6, 49. Add 6, 55. And add 6, 61. So we've gotten all 10 of them, but you had to have the previous term before you could get the next. Okay. Then it says find the 15th term of the arithmetic sequence in which t sub 5 is 7 and t sub 10 is 22. So a couple key pieces here. Obviously the t sub 5 is 7 and the t sub 10 is 22. But it said we were an arithmetic sequence, and we definitely want to find the 15th term. So right now, all I wrote down was a little sequence of what we know. So the sequence started off at some point, and then on the 5th term, based on what we have here, the 5th term was 7. And the 10th term was 22. So if you look at that, I think we're going to need to find that d value first, because we don't have a first term. So we know there is that constant d value going on. And between the 7 and the 22, which is the 5th and the 10th term, were 5 arithmetics, but only 4 numbers that go in there. So we have 4 arithmetic means that we're really finding. So this is what we need to do. We'll find that d value by first using our explicit equation. T sub n is equal to t sub 1 plus n minus 1 times d. We'll put our current last term in, which is the 22, which is our 10th term. We'll put the 7 in the first slot because it's a short little mini subset list, okay? So we're just looking at this list. Now I'm the first and I'm the, in this case, 10th term. And n minus 1, so we had 1, 2, 3, 4, 5, 6 numbers given, so that's why we chose a value of 6 for n. And n minus 1 is how many actual arithmetics we were doing, adding consistently here. And so add these up. We got 6 minus 1 is 5d. We had already moved the 7 to the other side. That's where the 15 came from. Divide by 5, and we get d equals 3. As soon as you know d is 3, you can start putting in the other numbers and or solve next for t sub 1. So using the same formula, put your d value in. Your n we knew now was t sub 5. We'll call that was 5. We're looking for t sub 1. We would have had 5 minus 1 or 4 additions to get there, and 3 was that constant difference. So you can see very quickly t sub 1 would have been a negative 5. Once we have that t sub 1, we can find the 15th term fairly quickly without having to show all those other terms in the sequence. T sub n equals, again, t sub 1 now we know is negative 5. We're looking for that 15th term. There would be n minus 1 or 14 constant differences, and that constant difference was a 3. Do the math. T sub 15 equals 37. So notice that we had to sort of do things in order, decide that we need to find d first. Okay. Once we found d, then we could go backwards and find t sub 1, still using the same equation. Once we had that, we could head to our final answer, which was t sub 15 in this case. Okay. I think we have one more. What about a real life situation? A new car costs $16,000. The value of the car depreciates $1,500 per year. Use a recursive formula to find the value of the car after 5 years. Excuse me. Then, in part B, use the explicit formula for the nth term of the arithmetic sequence to find the value of the car after 7 years. Now, I'm going to highlight, this is the key piece. The value of the car depreciates $1,500 per year, so that's key. So that's like, hopefully you're saying our constant difference. But in your statement on part A, use a recursive formula to find the value of the car after 5 years. So really, your sequence is coming from after the first year, after the second year, after the third year, after the fourth year, after the 5th year. So after the first year. So start thinking, what is your first term? You had a 1600 original. It depreciates $1,500 per year. So after the first year, what will that value be? That's how you need to start. And that will be our first part of our recursive. So did you start with t sub 1 equals 14,500? If you didn't, rethink that. It didn't say at the beginning. It said after the first year. So now we have to be able to calculate all the others. So all other terms in our sequence, T sub n, is going to be calculated by taking that previous term and again subtracting that 1,500. You can put a subtract in, you could add a negative, your choice, but this is what the recursive equation would look like in detail. So in words, T sub 1 equals 14,500. All other terms in our sequence, because of the for n greater than 2, which is a piece of the recursive, is calculated by taking the previous term minus that 1,500. So it's just repetitive. Then the part B. Actually, we got to finish part A because it says find them. So it just doesn't say write an equation. Use a recursive formula. So we're at 14,500 for step 1. After we take away 1,500, we're at 1,300. After we take away 1,500, what's the next step? Take away the 1,500. You can take away the 1,000 first, then the 1,500, your choice. We're at 11,500. After we take that, we're at 10,000. After we take away that, 9, and then 850, 8,500. So you can see what you need to do. There is another way in part B that says use an explicit formula for the nth term of the sequence to find the value of the car after 7 years. So we don't want to have to sit there and keep doing subtract, subtract, subtract. Put it back in. First term, minus n minus 1 times that constant of d. The math, we're looking for the 7th term, so n had to be 7. 7 minus 1 is 6. Do the math. We're good. Finish with a $5,500 for our 7th term. So we can use explicit, we can use recursive, whichever way we go. We're not finding the sum of anything, we're actually finding individual terms and the sequences that they are in. So if you have any questions, let me know. It's arithmetic, all based on a constant addition or subtraction.